All right, video 7 for chapter 5 is on proportional equations. So we're going to review a little bit how we determine if a table, graph, or equation is proportional. We talked about that a lot in video 6. We can write any proportional equation. We've looked at that a little bit already too. And we can describe the meaning of different points on a proportional graph. So we're going to dig a little bit deeper into especially proportional graphs here. So 4 things are going to be true for every proportional relationship. Okay, these are kind of things that will always be true if it's proportional. It's going to be a straight line. If you have a straight line, that is kind of a clue, and I'm going to put an arrow here, that you have a constant rate. Right? These kind of go together. If you have a constant rate and you graph that, it's going to be a straight line. I left a little room here because we also called this slope. We also called this constant of proportionality. That big long word, constant of proportionality. So rate, slope, constant of proportionality. Sometimes it's m in an equation. Sometimes it's the constant k, or coefficient rather, k in an equation. So those are kind of interchangeable. We know that it is going to have a 0 starting value. Maybe that shows up in a table, maybe it doesn't, but if you look closely at the whole relationship, the starting value has to be 0. So that was also evident in the graph if it went through the point 0, 0. Right? If it goes through the origin of the graph and it's a straight line, that's one way we could tell that the graph was proportional. And then the last one, if you're looking at a table especially, you have all proportional ratios. Every ratio you can come up with from points on the graph or different rows in a table, all of those ratios are going to be proportional. Okay, so just kind of some summary of things we know about proportional relationships. So we're going to look at a few different equations you might, or a few different types of questions you might see on proportional relationships. It says Mr. Howerton is ice skating at a rate of 3.7 miles per hour. Okay, write the equation. Well, I can tell they're giving me a rate here. Whenever I see the word per, that's a clue that they're giving me a rate. 3.7 miles per hour is the rate. So I can write the equation and just plug that rate in, 3.7x. That's the equation. I put the rate in right there. Okay. The starting value would be 0. If he hasn't started yet, he hasn't gone anywhere yet, I don't have to bother to write plus 0 as the starting value. What does the x variable represent and what does the y variable represent? I want you to go back to your label here, miles per hour. And if you recall from the last video, we said that the rate is always y over x. So if I have miles per hour, then y is miles and x is hours. So I'm going to say x is hours. If you remember from chapter 3, time is always the independent or x variable, so in this case hours, and the result or the outcome, the dependent from chapter 3, the y variable, here would be miles. But the easiest way is to just take this label and split it, y over x. All right, let's keep going. The equation y equals 17x tells the total number of french fries for x people. What does the 17 represent? The point of this question is just to see if you know that 17 is the rate. And if it's a rate, we can write it down with a label. So the rate is 17. 17 what? French fries per person. That's what the 17 means. Mr. Chenevert eats 6 pieces of candy per day. Write the equation. Well, 0 starting value, but I see a rate of 6, so y equals 6x. What's the x? What's the y? Let's take our candy per day right? We know it's y over x. So candy per day would look like that. That tells me that y is candy, or pieces of candy, and x is days. Again, that fits that the x variable is time, the y variable is the result or the outcome, like we learned in chapter 3. The equation y equals 65x represents your distance, miles traveled over x hours of driving. What does the 65 represent? Well, the 65 represents the rate. So it's telling you how fast you are going. And we see miles and hours. So you are probably driving. Yep, driving 65 miles per hour. That's what the 65 represents. When they ask you kind of what does that rate mean, they really just want you to label it. It's telling you your rate that you're going 65 miles per hour. Okay, now we have a double graph. It says we are going to find and interpret the slope for each person. You are the top line. So this is you and this is friend. I know you can't tell because it's black and white. Are these proportional? Well, they're both straight lines. They both go through 0, 0. So yes, and you could tell me why. Straight lines through 0, 0. All right, let's get the slope or the rate for each person. Since they are proportional, I can just do y over x for the friend. So let's see, friend, oops, I did that wrong. Friend is the top line. You are the bottom line. So friend, I could take either one of these points for the friend's line. Let's just use the smaller numbers, 28 and 4. We talked in the last video how y is the second number, so it's going to be $28 for y, and 4 hours. And if I get that rate, it comes out to 28 divided by 4 is $7 per hour. And that's also interpreting it, right? I labeled it. Your friend earns $7 per hour babysitting. Okay? How about you? You are the bottom line. So again, doesn't matter which one you use, but if I'm looking at this bottom line, let's just use the point 4 and 20. All right, x hours, y dollars. So when I do y over x, looks like I get $20 over 4 hours, which simplifies to $5 per hour babysitting for you. Okay, so we not only found the 5 and the 7, but we labeled them and kind of explained what they meant. So write the equation for each person. Well, we know it's proportional, so the starting value here is 0. The equation for your friend, they earn $7 times the hours that they work. And your equation for you, you earn $5 times the hours that you work. So you're simply putting the rate in here with the x for you, put the rate in here with the x for your friend. Okay, go ahead and flip to the next page. Who makes money faster? Well, your friend does, right? 2 ways that I know this. They have a higher rate, and they have a steeper line. Right? Their line goes up faster, and their rate is bigger. How much faster? Well, $7 minus my $5 means they earn $2 per hour more than I do. So simply taking and subtracting those 2 rates to see how much more they earn. Okay, we're going to go through some questions that go with this graph. First of all, how do we know it's proportional? There are 2 things we're looking for, if you remember, and this is straight off your quiz, so be prepared to answer this question. We know it is a straight line, and it goes through the point 0, 0. That's what I'm looking for. Has to do that if it's going to be proportional. What does the point 0, 0 mean? Well, I just need to label both of those zeros. It looks like I'm walking, so I could say in 0 seconds I go 0 feet. 0 feet in 0 seconds. Okay, how about the point 211? This question is making sure you understand that the first number has this label. Go ahead and draw an arrow if it helps. The second number has this label. So put that into a little sentence. 2 seconds, you can walk 11 feet. Or walk 11 feet in 2 seconds. Doesn't matter which way you say that, but the label on the 2 has to be seconds, and the label on the 11 should be feet. How about 422? 4 seconds to go 22 feet. 4 seconds to walk 22 feet. Okay, so any point they give me on that equation or on that graph, I should be able to label. Okay, what's the unit rate? Well, it's proportional, so I can take y over x for any of those. Let's take the y value of 11 and label it. The x value of 2 seconds, and actually divide that to get a unit rate. Well, 11 divided by 2 is 5.5, and the label right here is feet per second. And then I can plug that right into my equation. So y equals 5.5x. Plugging the rate right in there. Okay? A couple more questions to go with this graph. It says, what point on the graph tells us the unit rate? You are looking for the point on the graph that has 5.5 feet in 1 second. So I'm going to split this up again. And remember that that unit rate can be split. 5.5 feet in 1 second. This is the y, this is the x. So that would turn into the point x. In 1 second, I have gone 5.5 feet. So it is not labeled on here, but it would be the point right here at 1 second. This is at 5.5. 1 second, 5.5 feet. Okay, so if you just take that unit rate, y over x, and then turn it into the point, you get 1 comma whatever your unit rate is. This will be your unit rate. Okay? All right, 2 more quick questions. How far could you walk in 6 seconds? Well, I'm going to go back to this point right here, 2 comma 11. 2, nope, I'm going to flip it around and put y on top. 11 feet and 2 seconds, and use that to set up a proportion. Now they ask me how far could I walk in 6 seconds? Well, I need to line up my labels. So 6 seconds would go here, and I'm looking for x number of feet. Okay? I'm just using a proportion. Because this is proportional, I'm going to say set up a proportion. Exclamation point. If it's proportional, set up a proportion. So you can take any point from the graph, set it up, and then either find easy arrows or cross multiply. I see that this is times 3, so 11 times 3 gives me 33 feet. Okay? See if you can set up the proportion for this one. How long will it take you to go 20 feet? Right? 11 feet you could still use in 2 seconds. Finish setting that one up and cross multiply. Pause and hit play when you're ready to check that last one. Okay, so I lined up 20 feet on top. No easy arrow here for me, so I cross multiplied and got this equation, and I solve for x. So there is another example here with a different graph, but we'll save that and do it together in class, so you don't have to go any further right now. That's it for video 7.